Okay, niches. One of the harder things to really define in ecology, okay? And this encompasses, bless you, this encompasses much of what we talked about in the last discussion, on the first slide of the last discussion. When it comes to abiotic and biotic factors, we said that within an ecosystem, that organisms are affected by abiotic and biotic factors, and those organisms then therefore also have an effect on both the abiotic and biotic factors in an ecosystem. So when you look at that for a particular species, or actually even a particular organism, that which is affected by that organism and that which that organism is affected by, that's its niche. And that's why it's kind of hard to really pinpoint, hard to describe oftentimes what a niche is for a particular species. A lot of times it is talked about as the role in an ecosystem, place. I'll accept that because it's similar to what we're talking about. But sometimes the analogy is made with the job an organism has in an ecosystem, and that's a pretty good description when you look at what the ecosystem does for that organism, and what that organism does for the ecosystem, because that's what happens in a job. You do something for your employer pays you, so you got a back and forth relationship there. But it is many more things than that. It also includes habitat and climatic factors and all kinds of other things. So really, like I said, you have to encompass it in all the things that it affects and then that are affected by it. Group 7, I'm going to be kind to you and going to be generous, and I'm going to give you that because that is part of the niche, is what something consumes. But we're going to be very general here because, like I said, it is a general kind of definition. It is a very general thing. There's many different things that go into it. Okay. So abiotic and biotic. For example, let's say you've got a monkey in a banana tree. Okay. We'll start with the banana tree. The banana tree absorbs minerals and carbon dioxide from the environment. Therefore, those abiotic factors affect that banana tree. So that's part of its niche. It also relies upon bacteria to provide her with minerals, and relies upon respiring organisms to produce carbon dioxide for it to take in. And also it also actually depends upon being eaten, as we talked about how population control is a necessary part of an ecosystem. And so those are all the things, the biotic things and the abiotic things that affects that banana tree, and that banana tree has an effect upon. Okay, and then you got a monkey. So the monkey will eat the bananas from that banana tree. So there's another biotic thing that the banana tree affects, and that for the monkey now within his niche, that banana tree then therefore affects him or her. And therefore that's part of its niche. Then along those lines, the water that monkey drinks, the oxygen that the banana tree produces, he's going to breathe in. He's also going to do his business, leave his waste on the ground when he's done probably. There's a good chance he might carry the bananas with him, and therefore serve that tree, distributing the seeds from the banana, and therefore it affects that tree as well. So those are the abiotic and biotic things that affect both of those organisms in the ecosystem. Yes, Audrey?
What's the first one?
Oh, good question. Role is the technical answer. Sorry about that. Kendall, do you have a question, or was that what you wanted to know? Yeah, okay. All right, so now a big part of what is going to determine what the niche is going to be for a particular organism is going to be based upon its range of tolerance, because that's what it needs and what it can survive is going to be determined by what it can tolerate in an ecosystem. We already saw that bell-shaped curve. An organism would ideally like to be in the middle of that bell-shaped curve where it has ideal conditions, but a lot of times it can't. And either it's in a place geographically where it doesn't get those things, or you can draw that same curve for biotic things like food supply and those type of things, and it may also not have that particular food supply as well. But if you look at everything an organism can survive and can use, that's what's called its fundamental niche. So I'll give an example of people. Okay, we can eat, we're omnivores, so we can eat other animals, we can eat most plants and fruit. Okay, we can't eat grass. Our bodies are not adapted to digest grass. We do eat, actually eat mainly grains, but we modify them to eat them. But in general, we're not set up to eat those kind of things. However, let's say that you are in an area where there's not a lot of seafood available, for example. We can't eat fish, obviously. Or perhaps maybe you have some convictions that keep you from eating animals or those kind of things. So instead of being a carnivore, or instead of being an omnivore and eating all these types of things, you only eat plants, vegetables, and those type of things. You become vegan or vegetarian. That will be actually the niche that you fall into. It's not your fundamental niche. It's not what you're capable of as an organism, but it is a niche that you end up being in. And it's more so being forced into it. I just gave you an example of being a vegetarian by choice. It's not the best example because when we talk about, of course, in an ecosystem, we're talking about how you have to make do with what's available. So if you lived somewhere where they didn't have fish or fish was prohibitively expensive, then you would not eat very much of it or not at all. And therefore, that's what we call our realized niche. So what actually is realized, another way to look at this is what reality actually is. What in reality you end up actually utilizing is going to be your realized niche. Okay. Some species can occupy a wide variety of niches, so that is correct there. We call them generalists. They can survive in a number of different environments. They can eat a lot of different things. Cockroaches is an excellent example of it. Any kind of pest organism is usually, you can be pretty sure that is a generalist type species because they've learned to basically live with people, live off their garbage, live in their shelters and things like that, and therefore anywhere you find people, you'll find them as well. If they have a narrow range, however, we call them specialists, as you might imagine, that being the opposite of generalists. And these include both narrow ranges of abiotic factors, like if you remember, we talked about, the diagram of the stream, and where before the pollution was input, there's a lot of different organisms, including trout, and then where the organic waste went in, the dissolved oxygen dropped down, and a lot of those species either moved out of that or died. Those that survived were generalists. They had a wide variety that was a niche they could occupy, would be an aquatic system with low oxygen in it. The specialists in those were the ones that didn't make it in those environments, the ones you did not find in polluted water. Either they moved off or they died out. So that was an example of dissolved oxygen, or also a lot of times it's dietary. And so there's a lot of, well, I wouldn't say a lot, but there are certain organisms that have specialized diets, things that they in particular eat. And therefore, if you affect that particular food supply, it has a definite negative impact on that species. Example of those, anybody? Likes to eat bamboo shoots. Pandas. Another example I've given is koalas. Koalas typically eat eucalyptus leaves. So they can eat other things, but this is the mainstay of their diet. They're well adapted to digest. As a matter of fact, they have special enzymes that allow them to eat bamboo. The bamboo shoots, believe it or not, even though they're used as a food thing because they're cooked, but raw bamboo shoots in the quantities that they eat them in would be toxic to most other organisms. And if you think about that, it's limiting for them, of course, because they're, if something happens to bamboo, then they're in trouble. But it's an adaptation in that, and it's what we call a realized niche, in that if they're the only ones that are eating that, they've got, as long as that bamboo forest and everything's kept healthy, they've got a good food supply. They don't have to worry about other things eating their food supply. But also, if you get a situation where the bamboo suffers, then they're going to definitely suffer from that. Any questions about different types of niches? Okay, different types of species. Now we've talked about the components of the food chain: producers, consumers, decomposers, okay? But ecologists have identified certain types of species based upon a broader range of effects they have on different organisms around them. The food chain, of course, is the most common thing you can look at and see directly in the interactions of species in a food chain. I mean, in an ecosystem. However, there are many different ways, as I just discussed, with niches and everything, in which organisms affect their environment and are affected by their environment. So there's certain groups that those are put into. One of them is foundation species, and these species form the foundation of the ecosystem. So when you think about something that forms the foundation of the ecosystem, which need to be there to start the whole process going and everything, what kind of organisms do those tend to be? Producers, plants, etc. Correct. Producers is your correct answer for that one. And not just any kind of producer. Notice I put primary producer, so it's the one that's the most common in that particular ecosystem. Okay. So that's part of it. Unfortunately, like I said, ecology is full of half definitions or broad definitions or other kinds of things. But for some reason, ecologists have decided to also include organisms that have a major effect on the primary producers, or in some cases can actually clear out and strongly affect the primary producers in an ecosystem. These are also considered to be foundational. Example is coral. Now, coral's an animal. It is in the same order as jellyfish. As a matter of fact, part of their life, right after they hatch, they do swim around in the medusa form until they eventually take root and then they form the shells around them and stuff like that. However, coral have what's called an endosymbiont, and that means that they've got another organism that actually lives inside of them. And in the case of coral, in the individual coral animal cells, there are algae cells. This is actually what gives coral reefs their bright colors. That's the different types of photochromes besides just chlorophyll that the algae use to capture sunlight. Okay, so the coral itself, though, not only do the cells of the coral protect and keep that algae in there, so technically the algae is the primary producer in that ecosystem. However, the coral keeps them all together. The coral also forms a lot of structure, and that structure and habitat is a crucial part of the ecosystem because that attracts a lot more animals, mainly fish, of course, and those fish add to the food chain. They deposit their waste, so they then fertilize the algae that's in the coral as well. There's also back and forth between the algae and the coral itself, and so consequently, coral is actually the foundational organism in a coral reef, even though they're not the primary producer. So it's not only that, but also, like I said, if they have the ability to vastly change the primary producer in that ecosystem, then they're also considered to be a foundation species because that's what they do. They affect the very foundation of that ecosystem. Elephants are a good example of that. Elephants will go in and clear out entire areas of forest, uproot the trees, and destroy acres at a time in a given day. So much so that in some places the elephant populations, because they've been protected, have gotten high enough. They've been protected, yet they don't have as much habitat as they used to have, and they're actually damaging. They're having to, in many parks in Africa, they're having to actually actively go out and kill certain elephants and take them because they're damaging the ecosystem so much. But in a unaffected and a broad habitat world, this actually serves a function. It breaks down all the trees and stuff. It allows sunlight through, so a wide variety of other smaller plants and stuff can grow up. Eventually the trees will replace it through something called succession. But in the meantime, those elephants, by going in there, they've given the opportunity for a whole new group of primary producers to come in and take their place. Okay. Sea otters are actually something called keystone species. Sorry, they can't really, they don't have enough of an effect on primary producers. They're obviously not a primary producer because they're animals. So I'm not going to give you that one, group one, but good shot, good try. So what else do you know of that can just really clear an area of forest?
Clear? Like if it was just gone?
Yeah, man.
Don't like pigs or hogs.
Pigs can do that. Pigs and hogs. I will give you that. You're absolutely right. They can definitely uproot and do a lot of damage there. Termites are in that category, but I'm actually looking at one more familiar to all of you.
No idea.
Not pigs, not pelicans.
Pets. People.
People.
Homo sapiens. So we do that a lot. We clear out lots of different things. When we clear for a farm, we replace the primary producer of that ecosystem with one of our own choosing. So we're our foundational organisms. Now, keystone species, once again, and there's some overlap here. I will say this, and that's why I consider sea otters. Sea otters are typically considered to be keystone species, but they're not really on the level. They have an indirect effect on the primary producers, and they eat the things that eat the primary producers. So, once again, we can't give you sea otters for that one. But keystone species are, as the name implies, they're ones that if they play a very crucial role in that ecosystem, so much so that if their population numbers decrease, you can cause a significant drop in the biodiversity of that ecosystem. Collapse to where it's completely gone, no, but collapse is the typical term that's used just to represent a significant decrease in the biodiversity in that ecosystem. Tertiary consumers a lot of times play this role. In that they keep all the other populations in check. There's a constant balance. When you have a biodiverse ecosystem, there's constant competition that takes place through all these organisms, and therefore if one population grows out of control, it's going to significantly impact other populations. Well, when you have something down below you on the food chain, if you're a top level predator, the one that's most important is the one you're gonna get. It's gonna be the one that's out there and abundant, etc. And so therefore it will tend to keep all of those populations in check, and that's a very important role. Remember, I said population control is a very important biotic function. Also, another important characteristic of a keystone species is that if you remove it, there won't be something necessarily that's ready to take its place. So tertiary consumers, as we know, they have low reproductive rates. They're at the top of that ecological pyramid. And oftentimes it's hard to replace those tertiary consumers. Whereas a foundation species, when the elephants come in and they knock down all those trees, something else grows up in its place. And that's actually a good thing. In the case of keystone species, it's not that easy. So if you take them out, you're going to have a big problem there. The food chain, I'll take food web is actually better, more accurate, because with a web, of course, you have multiple connections, and you have webs, of course, in ecosystems. You don't have individual food chains in ecosystems. So when we look at a web, you can envision a web. There are a lot of times there are organisms that are near the middle of the web. If you remember those of you that did the field trip packet, certain things that go in the middle that both feed on a lot of different things, but also are consumed by a lot of different things. And therefore, if you get rid of that organism, you're going to have a lot of organisms that are going to be missing out, and a lot of other organisms that are going to be unchecked because of that. So if you can kind of think of a web, and if you just kind of cut a piece out of the middle of it, it can, definitely affect the structure. That's another way to look at that. Pollinators, a lot of times, particularly pollinators, because they're flying, and because particularly ones that can also participate in seed dispersal, like fruit bats, who will not only cross-pollinate because they eat nectar as well as eat the fruit. They'll cross-pollinate different plants like fig trees in the rainforest, and then they'll also eat the figs, fly over off somewhere, and disperse the seeds, which is also a crucial function. So if they have more than one of what you call your normal kind of niche functions in an environment that affects a lot of different organisms there, they're called keystone. Any ideas on where the term keystone came from, what its original application is, or what it is? Yeah, Andrew?
In archway, the keystone is the middle stone of the arch, and without it, it's going
Take that baby out, what's going to happen to the wall? It's going to collapse. Okay? And there's a lot of good architectural history. If you ever want to talk about that, I could share that with you, or you may know about it. It also is related to secret societies, interestingly enough. But no time for that now. Native species, that's pretty self-explanatory. Those are ones that they're not only that they've been there for a while, but they've been there long enough that they have adapted to the environment through natural selection, and they have very well-defined niches within that environment. You have non-native ones that just happen to have some either natural or human, for human reasons, which is more common now, of course. They're new to an environment, and they haven't quite established themselves. They haven't balanced themselves out, their populations, etc. It can take thousands of years for an organism really to fit into an environment where they can respond to all the different changes and stuff. And they don't have they balance out with the other species. Either they won't survive in some cases, or they'll be too advantaged for the health of the ecosystem. In that case, we call them invasive species. We'll have a lot more on that later, because that's a big problem when it comes to endangered species. And finally, indicator species. We talked about this a little bit before. These are ones that usually actually don't. They have a narrow range of tolerance.
It's sensitive.
And so when they are not present in an ecosystem, it indicates there's a problem. Or they can also be an indicator of a healthy ecosystem. So if you have a lake that has trout in it, you can assume trout's an indicator species, because trout need a lot of oxygen in the water. So you don't even have to use a dissolved oxygen meter. If you see trout in the water, you talk to fishermen, they say, yeah, we catch trout out here all the time. That aquatic ecosystem, that lake or whatever it is, probably a river, has high oxygen levels in it. Okay? So that's usually the way they are. They are species, narrow range of tolerance. Top level carnivores, since they're low in number, population numbers typically. If you have a lot of those, you see a lot of those, that means you've got a lot of food chain, food web supporting them. But sometimes they also are just because, not because they're narrow range, but because they're kind of out of place in environment, like fecal coliforms. What do they indicate if you find those in an environment? What kind of contamination? Fecal coliforms. Fecal. Poop, thank you. So probably from sewage or from animal runoff, okay? From farm runoff, that kind of thing. So that is an issue. That indicates that there's something going on in that ecosystem. So that's all. That's what we mean by the indicator species. Any questions? All right, so these really are basic biology concepts that I'm pretty sure you should have gotten in elementary school. So I'm a little bit concerned about this. Parasites, this is correct, predator-prey, crocodile wildebeest, we've seen the videos. By the way, I would suggest you check out Snoop Dogg's version of it.
Yeah, I saw it right here.
If you want to have a more urban interpretation of the interactions there. Pollination is a process. That's not exactly what I'm looking for, but it's close enough that you know what I'm talking about. It goes on between those two. I'll give you a point. What's the name for when two organisms help each other?
Symbiotic.
Well, symbiotic's all of these. Somebody get that for me, please.
Isn't it like...
Say
I know it starts with an M. I
mutually.
knew it started with an M. I knew it started with an M. Hello, Stanley.
Mutualism. Okay.
Who? Is Miss Naris here?
Naris. No, you got the wrong classroom.
No, you have the wrong.
Probably the wrong Campbell. He needs David Campbell. That's who he's looking for, or if they, or whoever it is looking for. All right. So, commensalism is when one organism is unaffected and the other organism benefits. Okay. I can't really. Now, fish is too vague. An eel.
It's close.
How? I mean, what?
What do you mean how? I mean, it's close. I mean, I just looked up a frill shark. That thing looked just like it.
Oh yeah, that's a good answer.
It's commonalism.
Commensalism. Commensalism. Remora.
What?
The remoras are the things. You guys don't know what remoras are? The ones that hang on to them. Yeah.
They're the Pokemon.
All right. So they hitch a ride. It doesn't really affect the shark. They get to eat the scraps that the shark doesn't eat, and they get a ride. They get transportation. you have a situation oftentimes with these species where they're competitive. Almost all of them are in some way. That means their niches overlap. They both have the same needs. If needs are part of your niche. When that happens, you have competition. A lot of times, organisms are smarter than we are, let's face it, in the way they adapt to things. Rather than constantly fighting over the same resource all the time, they will divide up that resource, and one will use part of it, another one will use another part of it. This is called niche partitioning. If we have time, when I get through this, I'll come back and give you an example. Partition means to divide up. Okay, so they divide up a niche. And like I said, I'll give you an example in a minute. The things ecosystem services. So one of the things I have tried to stress in this class is that preserving ecosystems and preserving the environment is not just about having nature to commune with, and although that's part of it down here, and having beautiful trees and stuff like that. We need it for many of our basic needs. And so even if you live the rest of your life inside in a room or whatever else, you need healthy ecosystems around you. Those things that ecosystems do specifically for us are known as ecosystem services. They include providing us with food and clean water, control of climate. We look at the fact that trees in particular absorb large amounts of carbon dioxide. Disease and a healthy aquatic ecosystem. A lot of the mosquito larvae and stuff that spread disease like malaria are kept under control. If it's a healthy aquatic environment, there's predators for their larvae. The nutrient cycles and crop pollination, of course, helps to feed us. Nutrient cycling is accomplished by bacteria in the soil, putting the nutrients back into the plants. And then once again, there is also the cultural, there's sometimes spiritual, some would say aesthetic benefits, as well as recreational benefits of having clean, natural, balanced ecosystems around. Some of your biggest environmentalists are hunters, hunting organizations. Now you can argue back and forth whether or not hunting is right or wrong, etc. But they are very strong in preserving land and therefore preserving organisms, because of course without them they wouldn't have game to hunt for. Niche partitioning, I said I was going to give you an example of this. The Anole lizard. Right, you know what I'm talking about? The little ones we see all over the place around here? Are they funny? Is that? No, okay. The Anole lizard is the one that you commonly see around here, is the brown Anole lizard. And that is actually a non-native species, kind of invasive. Yeah, I mean it is. How much impact it's had was overestimated at one point. And that is because when I was a kid, way back when, dinosaurs, of course, were wandering around and stuff, but the only type of lizard, the only type of Anole lizard that I would see, typically, were the bright green ones. You ever seen those? You ever seen the bright green Anole lizards?
Don't they change color?
They do, but they will, if they're in the trees and stuff, they'll be a bright green. That's the native species. That's Anolis carolinensis. Anyway, that's the native species that's here. And then in the 70s and into the 80s, the brown Anolis, or the Anolis negris, or the Cuban Anole is another word for it, native to the Caribbean area, they invaded. They probably got here on accident through people coming in, etc. And their population numbers grew very rapidly. Well, it looked like you didn't see as many green Anoles anymore. And ecologists were concerned, and they thought that the brown Anole lizard was seriously having an impact on the native Anole lizard populations. But what had happened, actually, is they didn't look far enough, because what had happened was the green Anole lizards just really, their population numbers decreased a little. You're going to have that happen. There's competition. But they moved up into the trees more. So their niche became, rather than having more of their fundamental niche was the trees, the brush, the ground, etc., their niche became more of a realized niche. So this shows both of those concepts. A realized niche of mainly feeding in the upper branches, upper parts of the trees and stuff like that. They're better camouflage because they can become a brighter green color, so if they need to get in the leaves and stuff. And the brown anole lizards actually, you know, their primary niche, their primary habitat where they hunt and everything is down on the ground in the bushes and stuff like that. Sometimes they go up in the trees, but they don't usually stay there. So that's, like I said, the niche itself is the trees as a habitat of the trees and the ground and everything. And they divided up and said, all right, we'll take this part, you take that part. That way we don't have to fight over the food and habitat supply. And that's an example of niche partitioning. Nocturnal animals. This is an example of niche partitioning. Nocturnal animals made use of the fact that they could hunt at night and had other variety of organisms they could prey upon at night, so they didn't have to compete with those animals that were actively preying and not preying, you know, like actively predating, I say the technical term, other species during the day. So those are all examples of niche partitioning, and it makes the greatest of, use of the resources by doing that. Any questions? All right, seniors may go.